Okay, exercise 11A. Okay, a smooth surface is inclined at 30 degrees to the horizontal. Okay, so this one is also an inclined plane where we have it is 30 degree to the horizontal, and then a body of mass should be straight 15 kilogram. Straight 15 kilogram lies on the surface and is pulled at a uniform speed of 10 meter. So 10 meter up a line of greater slope. So you move here 10 meter. You find the work done against the gravity. So this one is also just against the gravity. So W is equal to mg is 15, 9.81. Okay, so how are you going to find the height? So height would be here, and then you move 10 meter. So if let's say 10 meter here, so 10 meter height is here. So theta is here, which is 30 meter. So height is can use sine. Theta is so opposite over hypotenuse. So theta is 30. So H is 10 sine 30. Okay, so just use your dot calculator. 10 sine 30. So your answer would be 15 times 9.81 times 10 sine 30. So your answer is 735.75 joules. Okay, question 13. The surface is inclined in tan inverse 3/4 to the horizontal. Okay, and then the body of mass is 50 kilogram. Okay, so you have an object with 50 kilogram lies on the surface, and then it moves up 5 meter. Okay, along a resistance 50 Newton. Okay, find the work against gravity and the work against resistance. Let's say against gravity, so we have mgh. So it is 50 times 9.81. Okay, height. Where is the height? Should be height if let's say the object move up to here. So the height is here. Height here. So your theta here. So theta is tan 3/4. Okay. Or tan theta is equal to 3/4. So you have tangent. Okay, but before that, we just want to find h here. Okay, we draw the triangle for this first. Okay, tangent is TOA, opposite over adjacent. So this would be straightaway 5. So we're going to find h. So if let's say h, okay, h, this is 5 meter, and then you have theta. So how do you going to find theta? Is by using sine, which is h over 5. So h is 5 sine theta. So how you going to find 5 sine theta is from this triangle. So sine theta is equal to 5 so opposite over hypotenuse. So it is 3. So you just substitute 3 here. So your final answer would be 50 times G times 3. Your answer would be 1471.5 joules. Okay. And then for B is against the resistance. So F times D. So this one straight away it is 50. And then the distance is 5. So your answer would be 250 joules. Question number 14 is in a rough surface. Just now for question number 13 is a smooth surface. So the smooth surface and then it gave you directly the resistance force. But here you need to find the frictional force first. Okay. You need to find the frictional force and then the work done against the friction and the work done against gravity. So in this case, theta, your theta is tan inverse 5/12. Okay, and then the body is 130 kg. So mg is 130g and it is pulled up of 50 meter. Okay, and then the coefficient is 2/7. Okay, question A, find the frictional force acting. So you need to find mu R, which is the frictional force. So how are you going to find the frictional force? Okay, so your R would be here. So if let's say this one would be R, okay, and then your 130 would be here, theta would be here. So R is 130g, this is Fy, so Fy you need to consider sine, but because theta is here, so it is cos theta. So how are we going to find cos theta? Is from the triangle. So what triangle? So we have theta, tan theta is equal to 5/12. TOA, opposite over adjacent. So this would be, the hypotenuse would be 13. So how are you going to find the cos theta? So 130g cos theta is CHA. So adjacent over hypotenuse. So your answer for R is equal to 1177.2 Newton. So now you substitute back into your equation here. So you will get mu is 2/7 times with 1177.2 Newton. So times your answer will be 336.34 Newton. Okay. We move on to question B. Okay, find the work against friction. So work against friction is force times D. So your force here is mu D times with D. So mu is 2/7. Your R, we can just straight away because we already found the friction. So friction times with D. We already multiply just now. So I just straight away use frictional force times with D. Okay, so your frictional force is 336.34 times with this distance is 50. So your answer would be 16817 joules. Okay, for question number C, which is the work against gravity. So MGH. So M is 130 times with G. Okay, how about your H? So if let's say your object move here, and then so you're going to find this H. This is already 50. So theta. So we need to find opposite of hypotenuse. So would be the sine theta, right? So sine theta. So is 13G 9.81. Okay, your sine theta is from this triangle. So sine theta is so opposite 13. Okay, so you substitute here 5/13. So your answer would be 24525 joules. Okay, so this is your final answer for C. Okay, if the question asks you, in case you have question D, let's say question D, okay, find the total distance. Okay, if let's say the question is going to find the total distance, so how are you going to find the total distance? If let's say it's total distance, total work. Okay, if let's say the total work, so it means your work against friction plus the work against the gravity. So you need to add these two. 16817 plus 24525. So your answer would be 16817 plus 24525. So it is 41342 joules. Okay, you can proceed with the other exercise, question 15, 16, and 17.